We will be testing for independence in this video, and we're going to be using a new distribution called the chi-square distribution, and for technology we will be using Rguroo. So when you're testing for independence, you have to use a new distribution that we have not used before called the chi-square distribution, and it's a little different than your normal and your t distribution because it's not symmetrical. If you look here at the bottom, it is positively skewed. It's skewed to the right, and again it's called a chi-squared, and this is the symbol for it, chi-squared, but this is how you say it, chi-squared. So the area under a portion of the graph is still equal, just like for the normal and the t, is still equal to the proportion of the distribution in that range, also the probability of it being in that range. And just like the t distribution, the chi-square distribution depends on a degree of freedom, but the way you find degree of freedom here is slightly different. And just as with normal t distributions, there's a test statistic. So with the normal distribution, we used a z, and for a student t distribution, we used a t statistic. This time we're going to have a chi-squared statistic. Although for all of these, even though they do give us test statistics, we're focusing on the p-value method. So let's just talk about test for independence. When we're testing for independence, we're seeing if two factors are related to one another. And so you assume in the beginning that they're not related. And if they're not related, that means the two factors are independent of one another. So independent means these are not related. And if they're not independent, that means they are related. So if you'll notice, I'm pointing here to the null and the alternate statement, which happen to be in sentence form. They're not in mathematical symbolic form. So this is something a little bit different, but this is the template pretty much for writing out the sentences for the null and the alternate statement here. You would figure out what your factor 1 and factor 2 are, and you would say factor 1 and factor 2, whatever those are independent for the null. And the alternate statement, you would say factor 1 and factor 2 are not independent. You could also say that they are related. Factor 1 and factor 2 are related. You can also say that they are dependent. You can also say that they are associated. All of those things mean that they are not independent. So being independent means they're not related, not associated, not dependent. And then if they're not independent, that means they are related, are dependent, are associated. So the test for independence involves using a contingency table. We saw these when we were doing probabilities. We saw contingency tables, and the contingency table will contain observed data. So what are the numbers that did occur? And then when we run the test for independence, it will calculate what the values would be expected to be if the two factors were indeed independent. And those are called expected values. So we'll still compare the p-value to significance level. If it's low, we still reject. If it's greater than the significance level, we still fail to reject the null. And if we reject the null, we still say there is enough evidence to conclude H1. And H1 says that factor 1 and factor 2 are not independent. Or you could say are dependent. Or you could say are related, or you can say are associated. I'm giving you options here. Same thing for the fail to reject conclusion. There's not enough evidence to conclude that factor 1 and factor 2 are not independent. Or you could say there's not enough evidence to conclude that factor 1 and factor 2 are associated, because associated is the same thing as being not independent. Okay, so how do we put the table into Rguroo? So this is something that is new. So far when we've entered data sets. So this time though, you are going to go to data, in the data import drop down, you're not going to choose create data set. You're going to choose create new table. That's very important. So I'm going to put some stars by this. If you create a data set and try to run this test, it's not going to work. So you want to create a table. This is very, very, very important. And so just like with the data sets, you can add your rows this way and your columns this way. That part is the same. So it will have some similarities. But here are the differences. You get to label your row, each row, and you get to label each column. And then you can label all your rows and all your columns, which you will need to do. And then if you want to add a variable name, you can, or you can just leave it variable name like that. And then you'll enter your data into your table. And so it'll be usually more than 2 columns. It'll probably be several rows and several columns. Here's the big thing though. If you are entering data from, let's say, the homework website, if there's a total row and a total column, leave that off. Don't enter that into here, because that's going to add that total column and the row column in with everything else. And so we don't want to double the size of everything. So you want to only enter the rows and the columns that are not the total rows and columns. All right. So once we enter the data, how do we perform the test? So here's another difference. We're actually not doing a proportion inference or a mean inference. This time when you go to analytics drop down, you're going to choose contingency table. Contingency table. And it's actually a very quick test to run. First, you're going to choose your data set, and then you're going to pick your factor 1 and factor 2. And then for frequency, this is the variable. If you named it, great. If not, I think it'll just say variable. And so you'll click on that. And then you want to make sure that you click chi-square for the type of test. And if you'd like to see the graph, because we've been doing the graphs this whole time, and I usually ask you guys to paste your graph in for your work when you're doing a test, right? So go ahead and click graph so you can see that, and then you want to enter your significance level. So again, you want to choose your data set, choose your factors, choose your variable as your frequency, and that'll make more sense in a moment. Check chi-square and graph, enter your significance level, and then preview. And then you're going to get your p-value, which is what we're interested in. Okay, so here we go. I'll go ahead and tell you that, here, let me just show you real quick. If you go to My Groups, Show My Groups, and you click on your class, if you've joined My Groups, actually, I don't see it. One moment. All right, let me try this in. If you go to My Groups and click Show My Groups and click on your class, and this only works if you have joined my class, you will see I have all of the data sets for this lecture under Tests for Independence. So if you'll click Tests for Independence, you'll see I have 4 data sets for 4 examples that we're doing today. And you can click on each one of these and you can import the data sets, and they will appear under your data over here. So just so you know, that's available, but you do need to practice putting the data in as a table, just because this is new. Real quick, let's go back to here. And here's our example. Use the table below to determine whether the choice of major and hours of study are independent. So our 2 factors, you can get them usually either from the prompt, so variable 1 and variable 2, or you can get them from the table. So hours of study and major, you can get them from the table. So to write our null and our alternate statement, we would write variable 1 and variable 2 are independent. That means they're not related. And then we would say variable 1 and variable 2 are not independent. That would mean that they are related. Now, I like to write them this way as are independent and are not independent because this helps us to relate it to past statements that we made. We always made the null as an equality equal statement. So the word are could you could think of as meaning equals independence, are not equal independence. Now you don't write those symbols here, but I'm trying to show you the relationship between these and that it follows the same pattern as the ones we did with the symbols. We're still doing equality statements. And we want to fill in our variables. So major and hours of study are independent, and major and hours of study are not independent. So you want to fill those in. And so next we want to enter our data set. So you might want to I don't know, write it down. Either that or you're going to have to toggle back and forth, but you can pause the video so that you can get the data. I'm going to show you how you enter it though. Like I said, you can pause it and write it down on a piece of paper so you can then put it into Rguroo, or wait till I show you how to do it and then toggle back and forth. It's up to you. Let me get over to Rguroo real quick. All right, so you're going to go to data, and under data import, you're going to choose create new table. And so my table, just to remind you, it has 1, 2, 3, 4 columns and 1, 2, 3 rows. So I need to add 3 rows, 1, 2, 3, and 4 columns. All right. So for variable 1, you change the name of the columns here. Variable 1 was humanities, and then the next column, mine says variable 3, but don't worry about that because we're changing it. The next one was social science. Just show you I'm copying it from here. The next one is business and then engineering. So just double click it and then click up here and then type it in, business. Double click the last variable, engineering, and then double click in the row titles, and so we would say 0 to 10, and then 11 to 20, and then greater than 20. All right. And then this is really important too. You need to label your rows. So your rows, that's these. Those were, this label was, I'll just show you. These were labeled hours of study. Hours of study were the rows. Okay, so we're going to put row label hours of study. Column label, these were major. All right, and so you can leave this variable name or you can change it to whatever you want to call this. These are just number of students that are taking each of these, but again, you don't have to change it, so I'm just going to leave it. And we're going to type these in, 68, and then 119. I'm using the down arrow to go from cell to cell, and then for each column you have to click into to do the next one. 106, 103, 52, and then 131, down arrow, 127, down arrow, 51. The right arrow doesn't work, that's why you have to click into each column. 40, 81, 52. And then you would come over here and you would save it, and I would save it as maybe example 1, major, and hours of study, and then maybe I would hit save as. Okay, although I already have this saved, so I'm not going to save it again, but that's how you would type it in. All right, now when you click on it, I just want to show you, let me look it up, major and hours of study. I think I actually have this in twice. I just want to show you that it does translate your table into a data set, but because we put it in as a table, it has all the headings and everything it's supposed to have. So do not put these in as a data set. Put them in as a table. Okay. All right. So now let's run the test. I'm going to close that out because I don't need it. So the test, we're going to go to analytics and analysis, and we're not choosing mean inference or median or proportion inference. We're going to contingency table. You are going to choose our data set, which is major and hours of study. That's what I named mine. Factor 1 is major. Factor 2 is hours of study, but it doesn't matter. You can reverse it. You can do hours of study in major, and then you would have to click frequency and then choose that variable. If you named it, great. If not, don't worry about it, but definitely choose it. And then you'll click chi-squared, and the graph will automatically be chosen. You want to type in your correct significance level. In this case, we have 0.01 view, and you will see your contingency table. Now it may have so what it did for ours was it changed the rows and columns, but it's the same data, and notice it added totals for us, so you can see there's 1,000 students total. So a couple things. If you're asked for the test statistic, this is chi-squared, it's right here. If you're asked for degrees of freedom, to find it, I think it's rows -1 times columns -1, but when you run the test, it finds it for you, so that's 6. All right, so if you need the test statistic or degrees of freedom, you can get them from here, and your p-value is right here. It's 0.00001. Okay, so going back here, I'm going to add a page. So p-value, let's try to write this. Hold on. P-value is 0.00001, which is definitely less than 0.01. So if it's less, we reject the null, and so then we would say there is enough evidence to conclude H1. And what's cool about this is H1, we've already got it written as a sentence. So to conclude, major and hours of study are not independent, or you could say are related. So we've actually shown that they are related because they're not independent. All right. Next example. Well, I'll just let you look at that for a second. If you need to write that down, you can pause it and write it down. All right. Educational issues. All right. Rather than typing this in, I mean, you can pause it and type this in if you want the practice, or if you've imported it from groups. Awesome. So do people who are interested in educational issues visit museums more often than people who are not? In 2008, the General Social Survey asked 1,499 people how interested they were in educational issues and how often they had visited science museums in the past. The following table presents the results. Can you conclude that the number of visits to a science museum is related to interest in educational issues? So related means not independent, right? So for our null, we're still saying blank and blank are independent. For H1, I'm going to say blank and blank are, normally I say not independent, but because they use this terminology here, I'm just going to change it to related because that means the same thing. And then the two variables are number of, I'm going to just say museum visits. I think it's specifically science museum, but I'm just going to leave it as, well, let's just say number of, we'll just leave it as museum visits. And interest in education. Educational. Should have gave myself more room for this one. All right, so number of museum visits and interest in educational issues are independent, and number of museum visits and interest in educational issues are related. So we're going to go over to Rguroo. You want to enter that data set. So if you need to rewind the video and pause it so you can type that in, great. But hopefully you entered the data set, or that you imported it already. This one, ed interest is what I named it. All right, so if I go to analytics, choose analysis contingency table, my data set is educational interest. Factor 1 is, we'll just say educational interest, and factor 2 we'll say is number of visits, because it doesn't matter which is which. And then I just called my variable number. So make sure you click frequency and choose chi-squared, and significance level this time was 0.01. So we'll preview, and it looks like we have a p-value of 0.01347. If you needed the test statistic, it's 12.5884. Degree of freedom is 4. Here's the graph if you want to see it and see that p-value graphed. There you go. All right, so going back here, we would say this is greater than 0.01. Now, if you rounded it to 0.01, they'd be equal, and then you would reject the null. But because I'm not rounding it, I'm going to say that it's greater, not equal, so I'm failing to reject the null. I think this one is one of those. It's kind of it's borderline. It just depends on how you round it. So I'm rounding it to 4. Oh, I think I have it out to 5 decimal places there, and that is definitely greater than 0.01. So I'm going to fail to reject. So I'm going to say there is not enough evidence to conclude museum visits and educational interest, I'm shortening it, are related. All right. And again, if you rounded it to 0.01, then that would be equal to 0.01. In that case, you would reject it and say there is enough evidence to conclude that museum visits and educational interests are related. So it definitely is a borderline one. I'm going to go with that it's greater because I rounded it out to 5 decimal places. All right, anxiety and success. So test to see if anxiety level and need to succeed in school are independent events. What's interesting is you can't say that there's enough evidence to show independence, because that's the null. You can only show that there's enough evidence to show they are related or there's not enough evidence to show that they are related or not independent. So anxiety level and need for school success are independent. And then anxiety level and need for school success are not independent. Running out of room there, but that's supposed to say independent. All right. All right, so real quick, I have already saved this, but you can pause the video and enter it in as a data set. I'm going to go to data set and search anxiety and click on it there so that when I go to run the contingency table test under analytics, that's the only data set listed. Factor 1, need to succeed in school. Factor 2, anxiety level. And don't forget to choose your frequency. Choose chi-square. And significance level, 0.05 this time. Here we go. So, ooh, it looks like your p-value is really low. It looks like your p-value is 0. I don't think it's actually 0. I think that they've cut it off, that there's so many zeros in front of the first non-zero digit that they just wrote it like this. Okay, so looking here, if the p-value is 0, that's less than 0.05, so we're going to reject the null. And we would say there is enough evidence to conclude, H1, that anxiety level and need for school success are not independent. So kind of shortcutted it because I didn't have enough space there. So there is enough evidence to conclude anxiety level and need for school success are not independent. So volunteering. In a volunteer group, adults 21 and older volunteer from 1 to 9 hours each week to spend time with disabled citizens, senior citizens. The program recruits among community college students, four-year college students, and non-students. Is the number of hours volunteered independent of type of volunteer? So the two variables are number of hours volunteered and type of volunteer. So I've written the null and the alternate statement here. Number of volunteer hours and volunteer type are independent. And then number of volunteer hours and volunteer type are, and we can say not independent, or we can say that they are dependent, they are related, any of those for H1 work. Now, you can pause the video and enter this data, or if you imported the data already, you can just follow me now to Rguroo. So under data, I am going to type in the search. I'm going to type in volunteering or volunteer. Yeah, volunteering. And then now that I've clicked that, when I go to the contingency table and I click on data set, it's the only one that shows up. Now you don't have to do that, but I don't like scrolling down to all the data I have. And then the two factors are type of volunteer and number of volunteer hours. Again, it doesn't matter which one goes first. And then make sure you choose your variable under frequency, chi-square, and significance level is 0.05. We get a p-value of 0.0113, and there's the graph, 0.0113. So p-value 0.0113, which is less than 0.05. So we are going to reject the null. And if we reject the null, then that means there is enough evidence to conclude H1, number of volunteer hours, and volunteer type are, you can finish the sentence by saying that they are not independent. You can finish the sentence by saying they are dependent. You can finish the sentence by saying they are related. You can also say they are associated. Any of those work. All right, so notice for all of the conclusions, we never said that we could conclude that they are independent, and that's because independence is the null, and we can't accept the null or prove the null. We can only say we don't have enough evidence to conclude the H1, or we don't have enough evidence to conclude the H1, and the H1 is always that it's not independent, or that it's related, or that it's dependent, or that it's associated, whichever wording you want to use there. Okay, so that is all, I believe. Yeah, that is all. So have a great one. If you have questions, let me know.